Okay, so we've got the distance formula. Let's use that to find the distance between the points -2, 3 and 46, comma, -15. So I'm using 46 as x2 and -2 as x1. Do that subtraction and then square. So keeping this consistent, my y2 would be the -15, and I'm going to subtract from that the other y coordinate of 3. Square that difference. Add it all up and wait until afterwards to simplify your square root. 46 minus -2 is going to be the same as 46 plus 2, so 48 has to be squared. -15 minus 3 is -18. Square that. 48 squared is 2,304. And -18, since that's inside of what's being squared, a negative times a negative is positive. Well, -18, all of that squared is the same as 18 squared. So we get positive 324. Adding those up, we've got 2,628 underneath the square root. Now, to simplify that, if there is a perfect square larger than 1 that goes into that, then we want to find out what that factor is. There may be some shortcuts when you are dealing with some smaller numbers, but overall, since that's even, then we could divide it by 2. But that result is going to be even as well. So I want to see what's the largest power of 2 that I could divide by. If I divide it by 4, I get 657. That's not even. But 657 is divisible by 3. In fact, it is divisible by 9. So we would have, besides the 4 times that, split up the 657 into 9 times 73. Both the 4 and the 9 are perfect squares, and their product would be a perfect square. So we could factor 2,628 as 36 times 73, 36 being a perfect square, whereas 73, not only is there no perfect square larger than 1 that will go into that, it's in fact a prime number. So use the product rule for simplifying radicals, including square roots. And we would have the square root of 36 is 6. So 6 times the square roots of 73. You could double check that by getting a decimal approximation for the original. It's about 51.26 something. Whereas if we multiply 6 times square root of 73, I still get 51.26 something. But we're looking for an exact answer, simplified, so that there's no perfect square factor still in the square root.